mild success at least. So I didn't really want to connect anything up off camera, but after I took my time, got everything soldered up, really took my time, tried to make sure, pay attention to all the details and double check myself, triple check as I was going along. I did power this up for a couple minutes earlier. I didn't want to mess with, I didn't really want to do it off camera, but I didn't want to mess with bringing my power supply and all that stuff, setting up the camera out here if it wasn't even going to power on. I believe that that part's taken care of. I was hearing some pretty audible static for a change. I didn't hear any stations. The antenna was in a crumpled mess in the corner of my office. I had not adjusted the SWR or anything. I connected it, brought it out here to the garage and set it up in a kind of a haphazard way, connected my antenna analyzer, and the best I can get it down to, just because there's so much metal and other objects, and it's really not, the antenna is not set up too well in the garage. I mean, you can imagine a 60-foot antenna probably doesn't fit too well in a 2-car garage. So the SWR is down to about 1.7, 1.8, somewhere in there, right in the middle of the 40-meter band. And it's just a half-wave dipole. And so I've got this 2-pin connector, and I'm going to connect it up to the power supply. And then we'll turn it on and see what happens. So if I turn the volume up too loud, it oscillates. And I don't know how well you can hear that. Hopefully the camera's picking that up. As I tune this, at least before, I wasn't hearing any stations, no Morse code or anything. So I don't know if there's something else that's wrong. This is take my hands off that wire. That wouldn't be good for the tuning. But yeah, I'm not hearing anything. So I could go pretty slow. I may take a peek and see what frequency the oscillator's running at. It's working. It's not. I don't know if the reception's, maybe it's probably kind of bad because the antenna's just strolled around the garage here, and but it's definitely working. It took me a lot of work to get to this point. I struggled with it. It's Monday right now, and kind of over the weekend I basically just messed with it all off and on throughout the weekend, and I had various problems. I finally got it to work last night, but the audio was super quiet, and so today when I got in from work, I worked on it some more, and now the audio is very audible. So I'll kind of get a schematic here and show you some of the pitfalls that I ran into and some of the things that I'd like to change when I have the next iteration of this board made. We'll just tune it a little bit so you can see the tuning does work. I think the bandpass filter needs to be adjusted. I also think that the frequency is a little too, I guess that would be too high, because I don't start to really hear stations until I've got this screw backed almost all the way out. So I may have to make an adjustment to the number of turns on this tuning inductor. But yeah, I can't tell you how excited I am after working on it for hours and hours and hours and just being so frustrated. But hard work and persistence pays off. So one of the videos that I shot, there was no audio. Technical difficulty on my part. So, but that's okay because I'm just going to talk through everything I did here, in one take, hopefully. But because I'm so excited that I got the radio to work, I got myself a victory coffee. Because I'm 40 and it's a weeknight, so coffee's going to have to suffice. But I can't tell you how excited I am. I mean, building one of these, and I mean, people make it look so easy, but it was not easy for me. But when I heard that Morse code, I just about did a backflip. I was so happy because I spent so many hours on this. So, the first problem that I had, I printed out some of the original schematic, so you didn't have to just completely look at mine. So this is the original schematic from Solder Smoke, and okay, so these two transformers are the 5 to 28, 5 primary turn, 28 secondary toroids. And the mistake I made when I designed these in Easy EDA was I plopped down my symbol for this one and connected everything up, and then I plopped down my symbol for this one. Well, I didn't think about it, but this one needed to be rotated around. It needed to be mirrored on the page, and so inevitably, what happened was I connected on the actual board the wires on the transformer. I connected the secondary to the primary and the primary to the secondary. So I found that after kind of an hour, just kind of stared at everything, thinking about what mistakes I could have made. Because I was hearing static, but there was no stations getting through at all. So I was kind of thinking that maybe there was something in the bandpass filter that was wrong. And I cranked these variable capacitors to like no end. So that unfortunately did not fix the problem, but it did stop most of the oscillations, or pretty much all the oscillations that I was getting in the audio circuit. The buzzing and motorboating type stuff, that kind of went away. But then there was just kind of like no reception. It didn't matter what I did, how I connected it. There was just no reception. As I was saying, my daughters had to come tell me goodnight. Pretty much all the problems, and then the audio circuit kind of went away at that point. And I was just, at this point, I was just stumped. And I had checked it with my oscilloscope, and it was oscillating perfectly around 6.8 with the tuning inductor all the way out, and then all the way in it goes up to about 8. So really, seemed to be a pretty good range. And I don't remember what the voltage was, or the peak to peak, but it looked really nice sine wave. So I thought, okay, there's no problem with the oscillator, but why is there no reception? And I spent so much time. So one of the first things I did was I thought maybe I had substituted a 100 nanofarad or a 0.1 microfarad capacitor here in this audio diplexer. And I believe this is a filter to help filter out like AM stations, which I am getting an AM station a little. There's a pretty strong one in my area, and it doesn't come in. It's barely audible. It's only audible under certain conditions, but even with this filter, I'm still hearing it a little. But I thought maybe that capacitor substitution had something to do with it. and I don't have. It looked like um, in the instructional series from Salt or Smoke, it looked like I couldn't tell, but I think he was using a tantalum there, maybe. A 470 nanofarad ceramic would be a big ceramic. I don't have any that big. So I had put an electrolytic in there, and I guess I was kind of second guessing myself, and I ended up taking that out, and actually thought, you know what, you don't have to have this audio diplexer, so I just removed everything here, and then this inductor, I put a 0 ohm resistor across that pad, and that still did not fix the problem. And after several more hours of digging around on the schematic, I noticed another problem that pretty minor, but I'm still confused about this. I'm hoping someone will actually be able to explain this to me. This capacitor is the coupling capacitor for the audio. This is the audio amplifier, this circuit here. And again, this is my schematic, but it looks almost identical to the original. It's just drawn a little different, but I mean, it's the same circuit. But to me, that capacitor is backward. And this capacitor is backward, and that one's backward. But when you look at the original schematic, I had made a mistake, actually, because the one that's near the pot, if you look here at the audio amplifier, so you can see that capacitor, again, maybe it's not backward, but it seems backward to me. I've never seen one connected that way. But that one is, again, what seems to be backward. I mean, maybe it's not, but that one's connected the other way. And on mine, I had them all turned around. So I flipped this capacitor around. I actually put a through-hole component on the pad, on the surface mount pad. And it didn't change anything. It didn't change the audio at all. I turned all the capacitors around to the direction that I thought they should be in, and I tested it with my signal generator, got great audio, and eventually I actually just flipped them all back around the way that the schematic shows they should be, and I still got great audio. So I really wish someone could explain that to me. Like, how does that even work? I have no idea. There's so many things that I don't understand here. But either way, this was sort of, making me miss the forest for the trees. The bottom line was the audio was working great because I could hit it with my signal generator, and I mean, it's like super clear, very loud, really good. I mean, the audio amplifier on this thing is good. When you've got everything connected properly the way the schematic shows, I can tell you, I hit it with a signal generator, and I don't remember what the voltage was. It was less than a volt, and this thing was like, it was loud. I mean, I was like really shocked. So I said, okay, let me check the oscillator one more time, because it seems like maybe nothing's coming out of the mixer. And if you look here, I've got this test point, and it goes up and it connects to the source of this JFET. I think they call it a source on a JFET, don't they? And I mean, this is where I have the little 2-pin header, and I connected my oscilloscope here, and again, great sine wave. Well, I went to this LO net, local oscillator net. I have a test pin, which isn't shown on this paper, but it's in the schematic and it's on the board, and I got nothing, absolutely nothing, no oscillations on the other side of this JFET whatsoever. So I thought, okay, must be this new capacitor's bad. So I put my probe on this capacitor. Nothing. Nothing. The oscilloscope was just showing a bunch of, gibberish, basically. So I thought, wow, this is just, it's not, I mean, Not making sense. Must be a DC biasing issue with the JFET. So I checked it, and I got about 3.8 volts here. I got 9.25 here. And I didn't get any DC voltage here, which, I mean, you know, there's a capacitor here blocking DC, so you wouldn't really expect to get any. But I knew there was a good AC signal here because, again, test point, this pin 1 right here, I'm getting this really nice sine wave. So as I just checked the voltage over and over because this just was not making sense to me. And as I bumped one of the pins, I don't remember which one it was, I think it was the source, as I was kind of bumping it with my digital voltmeter, I heard the static get really loud. And so I never could really figure out what the actual cause was. I looked at it under the microscope, I zoomed in all the way. It appeared to be soldered correctly. It really looked okay. But I said, you know what? Let's just call a spade. So I pulled this JFET out. I put another brand new one back in its spot, and it came to life. But at that point, I started hearing the stations Morse code immediately. But at this point, I had another problem. The audio was like really quiet. Like you could hear the Morse code, but even with the volume cranked all the way up, you had to put the speaker up to your ear basically just to hear it. Now, it wasn't a figment of my imagination. I could hear Morse code. It was just so quiet. So I thought, well, maybe I lost something in the audio amplifier. Maybe I bumped something, or I don't know. Maybe another component came unsoldered with my hot air and I didn't see it. Hit it with the signal generator, beep, working perfectly. Perfect audio amplifier. So, you know, this is getting like kind of like late in the evening, and I said, all right, it's time to go, you know, to just go take a walk and just forget about this for a while, because pounding my head in the wall is not helping anything. And what it ended up being, well, I'm not 100% sure at this point. I'd like to experiment and see. And that's a lot of what this is, honestly. It's like, yes, I want to get the radio to work, but it's more important for me to kind of understand what's going on. That's the real cherry here. Well, actually, that's the sundae, not the cherry. The cherry would be getting it to work. But I put this audio diplexer back in. Now, remember, there was connection here because I put a 0 ohm resistor where that inductor is. But I'm thinking that inductor is actually really important. It provides some sort of coupling action from the mixer back out to the audio section. I'm not really sure. But I put all those components back in the way they were supposed to be, and the audio got really loud and nice and clear, and the reception was good, and we all lived happily ever after. So that's the if you stuck around this long, I appreciate it, because you know that was pretty long-winded. But that all everything that I just explained took place over the course of hours and hours of hard work for me. And I'm just so excited that this thing works. I mean, I could just sit here and play with this thing. And I know when I get my antenna up and I get where it's not in the garage, I think I'm actually going to put my antenna in the attic. I don't have a super big backyard. It's big enough for the antenna, but I think it would be much easier. My house is like a craftsman style, and it has a really big attic. I mean, I can stand up and walk around up there pretty easy. So I think I'm going to mount my antenna up there and run my coax upstairs to my bonus room or something. And so that might be a project for later in the week when my work schedule is not so tough. I can string it up outside and cut it and get it tuned well. But there are some other things that I'd like to do. I mean, just kind of looking at the schematic and some of the things that I've noticed. One of the things that I'd like to do is well, actually, I should show you. I had this paper kind of laying here from when I was kind of explaining some of the toroid winding stuff. I think it would be a lot easier, even though it's going to take up more space on the board, and I'm still kind of debating this, but I think I want to lay the toroid down sideways on the board, and I think that would help to actually be able to keep the leads on it shorter, and it would also, if I did that, then let's say wow, too much stuff on. If I had on the silk screen, I kind of had this circle. Then what I could do is kind of put, two pads over here and maybe two pads over here and two pads here, and it might be a little easier to hook things up and not get as confused like that. And then also I could sort of denote on the silk screen, like this one's the primary, and this is the center tap, and just and then even make a little diagram showing which two are physically connected, which ones go to ground, things like that. I think that would help me. And I mean, again, I really want to build. I'd love to design a circuit board that other people can make sense of, and that they could have built, and they could make this same circuit if they want, or same thing if they wanted to, without having to suffer all the learning curve of figuring out a good layout for the board and everything. The other thing that I'm worried about is I was hearing a lot of static in the audio section, even when I don't really think there was any signal getting through because of the problem with the local oscillator. So in theory, there really shouldn't have been much of anything coming through. Like, to me, the audio should have been kind of almost dead, maybe. And I'm not 100% sure on this, but I'm sort of thinking that maybe the audio amplifier section should be better isolated from the rest of the radio to prevent stray RF from making its way over there. Now, I'm not entirely sure that that's what's happening, or that that's what happened, and I could test that theory. I could desolder that L11 inductor, and I could even go as far as desoldering the coupling capacitor for the audio, and just kind of seeing, like, do I still hear any static? Because if I did, then I would think that would be a sign that the audio amplifier is picking up stray RF on the board, and which indicates that I could probably do a better job on the layout. Well, there's no probably about doing a better job on the layout. It could definitely be better. So yeah, there's just a few things that I could do. Another thing is I've got kind of a mix of a couple different sizes of SMD components. I would like all those components to be 1205 or 1205s or 1206. Why do I always get that wrong? Just because they're just a little bit easier to work with, and I'm not super sure if I want to stay with the surface mount capacitors or just go with the through holes, honestly, because to me, I love surface mount, but I'm not sure those are really any easier, and they take up about the same amount of space as a through hole. So I could even build sockets for the toroids, possibly. That way, if a mistake was made, it would be easy to pull it out and stick it back in. I thought about that. There's just a myriad of things that I could do to kind of make the layout better. So I think I'm going to kind of get to work on redesigning it and coming up with a little bit better design now that I have a proof of concept. So I appreciate y'all hanging out with me and sharing this excitement with me, and we'll see you in the next video in this series.